This is the 3.5 day one set of notes, and hopefully most of this material is review for you guys because this concept was actually taught in 8th grade, and we're just going to be adding on to what you already know. So let's look at what you should already know. So the first thing that we did in our notes was we described the slope of the line. So what that means is we are looking at the line and determining if it has a positive slope, a negative slope, zero slope, or undefined. So I showed you a video today of Slope Dude to kind of help you remember this, but hopefully you guys remember that a line that slopes up from left to right is considered to have a positive slope. And Slope Dude said, puff, puff, positive, puff, puff, positive, as he tried to go up the slope, or up the steep hill. Then a slope that slopes down from left to right is considered to have a negative slope. And Slope Dude said nice, negative, when he was skiing down the slope. Okay? Then we have our horizontal line, which, remember, this is the second time we've talked about horizontal lines, and I taught you that acronym HOI, and I told you that horizontal lines have zero slope, and they are y equals a number. So this horizontal line has zero slope, and Slope Dude said, this is zero fun, when he was trying to ski along the flat portion of the hill. Okay? And then our last slope is this vertical line. So remember our acronym was VUX, and VUX stands for vertical lines, undefined slope, x equals a number. So Slope Dude said undefined whenever he fell off the side of the mountain. Okay? So those are the 4 types of slope that you should be able to describe. Those are the descriptions. They're either positive, negative, zero, or undefined. So the next thing that we talked about on our notes was how to calculate the slope of a line by finding the ratio of change in y, which we call rise, over the change in x, which we call run. So that ratio, when it's written, is going to be written as rise over run. And then, like I said, that's change in y over change in x. Remember that little triangle? It's a delta. That means change. Okay, so if you look at this little example they've given us, when you are looking for the rise over run, remember your rise could actually be represented as a negative number, because here I would fall and then run left. So if you rise, if you go up, then that's going to be positive. If you run right, that's also positive. If you fall, that's negative, and if you run left, that's negative. So there is an actual formula that you can use called the slope formula, and that is y2 minus y1 over x2 minus x1. So what that means is if you're given 2 points, we're going to call those x1, y1 and x2, y2. You can calculate your slope by using this formula. You subtract your y's and you write it over the difference of your x's. So that's how we calculate our change in y over our change in x. You're going to use this slope triangle, this rise over run ratio, if you're actually given a line where you can count the slope. Okay? You're going to use the formula if you're given 2 ordered pairs or if you have a table of values. Okay? But all of this means the same thing, and that's going to give us our slope. That's how we calculate it. So let's go ahead and look at a couple of examples. So in these 2 examples, it's asking me to do 2 things. It's asking me to describe the slope, which, remember, describing just means tell if it's positive, negative, zero slope, or undefined. So let's go ahead and look at this first one. I see that this line is sloping up from left to right. Therefore, this has a positive slope. Okay, so that's my description. Then it asks me to actually calculate my slope. So I can do this 2 ways. the first thing I can do is use that slope triangle because I'm given a graph and I can just count my slope. So I notice that in this graph, that if I was to start on the point, that I would rise 4 to get in line with that point, and I would run a total of 6. So my rise was rise positive 4. My run was to run 6, which this would reduce to 2/3. Okay, so I could use that slope triangle and actually count. I'm counting the little boxes. This is 1, 2, 3, 4, and I have to go over 6. Now notice they also labeled these 2 points. So I could also use my slope formula. So if I'm going to use this point as my x1, y1, and this point as my x2, y2. So if I do y2, so that would be -2. So -2 minus my y1, which is +2, over my x2, which is -3, minus my x1, which is 3. So -2 minus 2 is -4, and -3 minus 3 is -6, and -4/6 still reduces to 2/3. Okay, so this is my slope if I use slope triangle. This is my slope if I just simply calculate the slope. Notice they are exactly the same because the slope of the line is 2/3. That's the rate of change. That's how many points you move up and over to get back on the line. Okay, why don't you guys pause and see if you can do the second example on your own. Okay, so for this second example, the first thing I did was I described the slope of the line. I noticed that this slopes down from left to right, so my slope is negative. So when I use my rise over run, if I rise 3 and run 2 to the left, that makes my slope -3/2. Now, don't get bogged down in, well, does the negative go with the 3 or does the negative go with the 2? Saying 3 over -2 and saying -3/2 are the same thing. So my slope is -3/2. Now, one of the things that we talked about also is if you have a positive slope, then when you calculate your slope is actually a positive number, a positive ratio. Here, my slope was negative, so when I calculated my slope, my actual ratio was negative. So I went up 3/2. Okay? Okay, so on these next examples, the only difference between this and what we just did is they didn't actually draw in the little triangle for you. So if you're using slope triangle, you can draw that in yourself, and I'm going to show you how to do that. But first, let's go ahead and describe the slope of each line. My first line slopes down from left to right, so I know that it has a negative slope. My second line slopes up from left to right, therefore it has a positive slope. My last line also slopes up, so it has a positive slope. If you'll describe your slope first, it will help you remember that when I calculate my slope, this should be a negative number. These two should be positive numbers, okay? So it's just kind of a self-check thing. All right, so let's go ahead and calculate. So on this first one, I'm going to use the slope triangle. So I'm going to start at the point that they gave me on the left, and I'm going to go down to get in line with the other point. I notice that I have to fall or go down 2 units. So my change in y, or my rise, is actually equal to -2. In order to get in line with the point, how many do I have to move over? I have to move over 1, 2, 3, 4, 5 to the right. So I know that my change in x was equal to 5. So the slope of this line is -2/5. That means I went down 2 over 5 in order to calculate my slope using that slope triangle. Okay, so for the second line, I'm going to use the formula. So I'm going to write down my points first. I have -3, -1. which I'm getting that from the actual graph right there. And I'm going to go ahead and label that x1, y1. Okay? Then my second point, which is up here, I'm going to do that one. So that's 3, 3. And I'm going to label that x2, y2. And that's just to help me remember when I'm using my formula, because my formula is y2 minus y1 over x2 minus x1. I don't want to forget which one I'm calling my first point and which one I'm calling my second point. Okay? So let's go ahead and fill in our formula. So we have y2, which is 3, minus y1, which in this case is negative 1. So remember, when you have minus a negative, it becomes plus 1, over x2, which is 3, minus x1, which is negative 3. So minus a minus becomes plus, so we have 3 plus 3 on the bottom. So now 3 plus 1 is 4, and 3 plus 3 is 6. 4/6 reduces to 2/3. Notice it's positive, just like I described my slope as a positive number. Now I could always check to make sure I did my formula correctly when I have a graph by just using the slope triangle. So if I start on this point, how many would I have to rise? Well, I would have to go up 4, and then I would have to go over 6 to get in line with that point. So I know that my slope is 4/6, which reduces to 2/3. You could also use that 2/3 by looking and seeing, well, if I go up 2 and over 3, look, I'm back on my line. So 2/3 and 4/6 are equivalent because the slope of the line, I could go from this point to this point, 2/3, or if I wanted to double that and go up 4 over 6, it still works. Okay, why don't you pause and do the last one on your own? Okay, so for this one I decided to use the formula because when I went to start doing my slope triangle, it looked like it was slightly off on my graph and I didn't want to make a mistake. So I labeled this point as my x1, y1, and this was my x2, y2. Then I just filled in my formula. So y2 is negative 3 minus y1, which was 4, over x2, which was 2, minus x1, which was 5. Negative 3 minus 4 is negative 7. 2 minus 5 is negative 3. And a negative over a negative becomes positive 7/3. Do not leave it as a negative over a negative. You knew this slope was supposed to be positive because the line slopes up from left to right. Okay? For this next set of data, instead of giving you an actual graph, you are given a table of values. So they tell you up front that the points represented in the table lie on a line. So we are going to find the slope of each line from the table by finding the change in y over the change in x and writing it as a ratio. So that's the same formula we've been using. Now you just have to determine what do you want to use as x1, y1, and x2, y2. You can use any points. I'm just going to choose to use the first 2 points on this one. So y2 would be 14 minus y1, which is 20, over x2, which is 7, minus x1, which is 4. Okay? So 14 minus 20 is negative 6, 7 minus 4 is 3, and negative 6 over 3 is negative 2. That would represent the slope of that first table of values. Okay? All right, let's go ahead and look at the next one because hopefully you're noticing that right here, all my y values are 2. So think about what that would look like. If I went to negative 1 and up 2 and put a point, and then I went to positive 1 and up 2 and put a point, and then I went to 3, 2 and put a point, that's going to wind up making a horizontal line. So you should be thinking, oh, that's HOI, which if you know what HOI stands for, a horizontal line is going to have 0 slope. Well, let's look at what that looks like when I try to calculate it. So here, y2 is 2, but y1 is also 2. So in my numerator, my change in y is 2 minus 2. Then for my x1 and x2, so x2 is 1 minus a negative 1. Well, 2 minus 2 is 0. and 1 plus 1 is 2. Now, oftentimes when kids get ratios that involve 0, they get confused. So 0 divided by 2 is 0. This line actually has 0 slope. But to help you remember, if 0's on top, it's okay. All right? That equals 0. If 0's on bottom, so if 0's down here, that's no. So this is not okay, and that was when it would be undefined. You could also just use a calculator, and if you divide 0 by a number, you're going to get 0. If you try to divide a number by 0, it's going to tell you error, cannot divide by 0. Okay? All right, why don't you guys pause and see if you can do the next one on your own. All right, so on this one, you should have noticed that all your x values were the same. So if x equals the same number, that's going to be a vertical line, so you should be thinking VUX, and vertical lines have undefined slope, and those are x equals a number. So when I go to calculate and I do 0 minus negative 3, that's where 0 plus 3 came from, I get 3. But when I do negative 3 minus negative 3, that's where this plus 3 came from, I get 0. So remember, 0 on bottom is NO. So you need to interpret what this means. 3 divided by 0 is undefined. So I know that this table of values has an undefined slope. At the end of our lesson today, we talked about tables that have the data written this way, which sometimes for some reason throws people off. And I just wanted you to remember that when you write your slope, it's always change in y over change in x. Don't let the way the table is written throw you off. So when I go to calculate this data, I'm still going to do 15 minus 10 in my numerator because y goes in my numerator. And then 4 minus 2, my x's, go in my denominator. 15 minus 10 is 5, and 4 minus 2 is 2. Therefore, the slope of that data is 5 over 2. All right, go ahead and pause and do the next one and check your work with mine. That last table of value, if you noticed, it had x equals 5 all the way across. That would be VUX. That's a vertical line with an undefined slope. But if you tried to calculate, you should have noticed that when your denominator was 5 minus 5 is 0 on the bottom, you could have stopped right there and said it was undefined. Okay, this is not the last day we will work on slope. We will be working on this for a while, but if you have any questions and this video is not helping, please make sure you come in for tutoring. Have a great night.